I am Surya Balakrishnan from Cloudera. I'm here with my colleague Vedant, where we'll briefly talk about Airflow at Cloudera and specifically our Cloudera data engineering, which is our managed Apache Spark and Airflow offering. So brief agenda for today, we'll quickly touch upon Cloudera data platform, which is our main product, then talk about the current pain points in the data engineer's lifecycle, why we built CDE or Cloudera data engineering to solve them, a bit about the high-level architecture of our product. Then I'll run you through a demo of Airflow in our Airflow offering, and then a bit about our low-code editor. Then talk a little bit about the operators we created. Then the challenges we've faced so far while running Airflow for in production for our customers, and then talk a bit about our internal uses of Airflow at Cloudera, and then I'll conclude. So what is CDP? It's a hybrid data platform, enterprise one for all your data management needs. So it can run on any infrastructure. So we support on-premises servers and public cloud. We currently support Azure, GCP, and AWS. You could also be a mixture of both. And some stream processing software we support on edge servers as well. So on top of this base infrastructure layer, you have Cloudera SDX running, which is shared data experience, which is a set of common services we built for which will be used by the higher layers of our product. So these are built using Apache Ranger and Atlas. This gives you a good security and you can control your data access at one level for all your data products. And it also helps in governance. So you can see who accessed what, and you with Apache Atlas, you create one copy of metadata, which is replicated across multiple products. This way, you don't have to keep, when we try to keep multiple data copies of metadata and sync, there are some problems, and Apache Atlas solves that problem for us. On top of this, we have a data hub, which is our cluster form factor, where you give us your parameters, we spin up a cluster with multiple different services installed on them, like Spark, Hive, HBase, etc. But this is a cluster form factor, and the full freedom is given to our users. They can customize whatever parameters they want. But we've noticed many of our users didn't want this high level of management. They said, hey, I'll give you my application, you run it for me and give me the output. And so based on their feedback, we've created our next generation of products called data services. We have 5 of them so far. These are for your end-to-end data lifecycle management. So we have data flow and streaming, which uses Apache Kafka and NiFi, which is for taking data from edge devices or any stream input. And then you can use our data engineering offering with Apache Spark to clean up that data and then put it into your data warehouse. Our data warehouse offering is built with Apache Hive. And so you can keep your data there. And we have this operational database offering built with Phoenix. So that is for real-time analytics. So usual databases, they take a bit of, it's more batch processing. So it takes time to host your data. With the operational database, you can build up real-time applications on the same data. And after that's all done and you have your data clean, we have a machine learning offering which supports multiple different libraries for any data science, analytics, or predictive stuff on your data. And with this entire set of suite, we have a good, you can manage your entire data. And on top of this, we have a management console, which is a web service for managing your the product. So you can specify identity and access management so that you can only authorize users are allowed to access your services and not anyone else. And you can also manage your clusters and environments from this top layer. So a bit about the challenges we've seen so far while running production Spark jobs for our customers. One, it's hard to manage Spark resources, as in your cluster parameters, how many resources to give, etc. And it's a bit difficult if they have to create complex pipelines, dependencies between tasks and all. They have to write a lot of custom code. And they needed visibility and troubleshooting. So it's important to profile. Suddenly your resource usage shoots up, then the admin is on fire. And so they need to quickly debug what's going wrong and fix it. And we also need to reduce the data engineering lifecycle. So it takes some long time to test, deploy, and then see your changes and create a loop. And so we wanted an easier method for them to deploy faster. So a bit about, with these problems in mind, we built CDE or Cloudera Data Engineering, which is a managed Spark and Apache Airflow service. It's built on best in breed open source tools so that we give the best data engineering possible experience that we can. So if we use Apache Unicorn Spark and Kubernetes it runs in a containerized environment. So Apache Unicorn we use for optimized resource scheduling. So Unicorn is a replacement for the default Kubernetes scheduler. What we've noticed while running big data workloads is the default scheduler's performance is not good enough. And especially burst jobs or something like that, Unicorn performs much better because it uses slightly different algorithms. And since it's a containerized environment, you can have multiple different Spark versions on your same cluster. Usually you don't have to have only one Spark deployment in a cluster, and you can quickly toggle between the two so that you can run your old applications and new applications as well. And since it runs on the cloud, the cluster auto scales with your workload. So as your workload requests more resources, your cluster will scale as well. Now we've used Apache Airflow as our orchestration engine. It's an open source tool which is widely known. So many of our customers are familiar with it. If they can create DAGs, they can easily orchestrate their Spark jobs. It helps them in building complex data pipelines with multiple dependencies between the tasks and etc. And if they want to schedule it to run at a regular interval, it's very easy. And so we've also used Fluentd, Prometheus, and Grafana to build a real-time metrics dashboard. So that helps them in visually seeing their performance of their cluster, and it also gives alerting capabilities. So in case suddenly memory or CPU usage shoots up, they can go ahead, get alerts, and then quickly debug which job is taking most resources, and either shut it down or take the appropriate action. Now we use Apache Livy for simplified job management, and Livy is a REST API for Spark. So the Spark API wasn't as good enough for creating and managing Spark jobs. So this REST API gives an easier interface for users to create Spark jobs, manage their lifecycle, etc. And so this makes the developer lifecycle much better, and they can quickly test their change and then deploy it. So this is a bit of our high-level architecture. So we have one Kubernetes cluster which runs for each CDE service. Within that, we have virtual clusters, which are partitions of that service, so that you can have multiple different users using the same cluster in isolation. Each virtual cluster will have one instance of Apache Spark and Airflow running. The base layer could be either public or private cloud, and we use each cluster has one instance of Unicorn running, which acts as the scheduler. This will scale up with your application, and we have one instance of Livy running so that you can easily submit your jobs, and Grafana and Prometheus run for metrics collection. So your data engineer would typically come, say, hey, let's start creating your job, quickly deploy it, iterate on the changes. Once they're done, they deploy their job. And if it's one of those jobs that need to be run on a regular interval, they schedule it so that using our Airflow scheduler, it would keep running scheduling, and then using our dashboard, then monitor or get alerts based on resource consumption, etc. And this covers our entire data lifecycle for data engineers, sorry. So why did we use Airflow and CDE? There are multiple different use cases we wanted to solve. So we'd say, hey, schedule this particular Spark job to run every day at 9 p.m. Or if I want to create a complex workflow of some Spark jobs, some Python tasks, etc., and have dependencies between them. And it also allows us to run multiple different kinds of jobs, Python, Bash, Scala, Spark. And then because of the connectors approach, it's very easy to integrate with our other CDP services. So in one place, you can orchestrate our entire suite of products with, as example, data warehousing, machine learning, etc. You can orchestrate from one place. So a few points on our architecture. So it runs on Kubernetes. The deployment is fully automated. So they specify some few configs and then they click create. It's isolated at a virtual cluster level. So this means that each virtual cluster has clear quota management. So let's say one team starts using too many resources, it doesn't impact another team. And it also allows us to specify finer grained access control for each virtual cluster. So you're effectively sharing a cluster, which leads to better resource utilization. And one shared Airflow instance, but only few users. All the users of a virtual cluster would share that one Airflow instance. All our DAGs will sit on a shared file system, and most of the metadata lives on the cloud in a database. So a quick demo. So as you see, this is our UI. This is the home page where we have a list of virtual clusters here. you'd once you click on the administration page, this is a better view for managing your clusters. So you have all CD services on the left, which are each CD service is one Kubernetes cluster. Right now, multiple different clouds. It's each cloud has some. You can connect them to your account, so you can run on multiple clouds. And within each CD service is one virtual cluster on the multiple virtual clusters on the right. These are basically namespaces in Kubernetes, and with Unicorn we can give clear quota management, and we use our other IAM software for access control. Now, to create a DAG, you just point out and say, hey, which virtual cluster you want to run it on. You specify a name so that you can track the job, and then you just go ahead and upload your DAG. As simple as that. So for this example, I chose a fairly simple DAG. So once you upload your DAG, you have to upload it in a resource, which is our abstraction of files. So we've noticed that some files are used between multiple jobs, and you don't want to keep re-uploading them. So you are uploaded to a resource. It's stored in an object store, and then it can be reused between multiple different jobs. So once it's done, I'll quickly show you the DAG. It's a fairly simple one. It's just scheduled to run at 12 p.m. every day. And then it has a few dummy and bash operator tasks. And on the last line, I specify the dependencies between the tasks. And so once I'm done, I can go ahead and create the job. And soon after the job is created, I'm navigated to this jobs page where I can list and manage all my Spark and Airflow jobs. On clicking on an Airflow job, I can quickly navigate to the familiar Airflow UI, where I can get more insights on task level failures, retries, etc. So this is a very simple DAG with 4 steps. The fail step was always set to fail. And you can see that, hey, okay, this fail, if a production customer would say that, okay, the step failed here, let me look at the logs and try debugging what went wrong. So we've also noticed that some of our customers don't know what DAGs are. So it's you have to, Airflow is a syntax at the end of the day, even though for us programmers, it's very simple. For people who are not very familiar with code, it's a bit complex. They have to learn the DAG structure, function thing, what the function signatures are, and etc. And so we wanted even those customers to be able to create complex data pipelines involving multiple different steps. And to do this, we've created a low-code editor. So to create it, you'd again say, hey, choose Airflow type, but instead of uploading a DAG, you'd specify the editor option. And once your editor job is created, you're navigated to this drag and drop editor, which is a low-code editor for creating DAGs. We currently support 4 different operators, shell operators, which are basically simple shell tasks. And then we have this CD job operator, which is basically a reference to an existing Spark job. So you create a Spark job somewhere else in CD, and then you can reference it here in this low-code editor. We also support CDW queries, which is our way of running Hive queries running on your data warehouses. So once we've created, we can specify which bash command to run. For simplicity, I just say echo start for the shell command. And in the CD job, I reference job I pre-created, which is a simple job that calculates the value of pi. And here we can either, in our Python operator, we can either support inline code or reference a file, because sometimes your amount of code is a bit large. So all of it won't fit easily on this inline code editor. Once you're done with your multiple steps, you can quickly connect the steps and add dependencies. So CD job run will run after shell 1 finishes, Python 1 will run after the other 2 finish. Once I'm done editing, I go ahead and save my DAG. And then I can go ahead and once it's saved, I can go ahead and run it. So once the job's run, I'm again navigated to this jobs page where I can again quickly navigate to this the Airflow UI, where I can see my low-code editor DAG was converted to an Airflow DAG, same shell 1, CD, job 1, Python 1, the same steps that we've described earlier. And these run, and here you can quickly monitor which tasks have failed, etc. So yeah, click the right again. Yeah. So one thing we've noticed is we are a managed airflow offering. So because of that, we do not let the customer set all their configs or parameters they want. Some of their customers are very hands-on. They have a specific type of configs or parameters they want to set. And so we said, okay, you can go ahead and use your own airflow instance running anywhere. But if you want to use our managed Spark offering, you don't know much about Spark or Hive or something, and you want a managed way to run or those jobs, you can orchestrate it from your Airflow instance using our open source operators. Right now, we have 2 operators which are open source. We're working on adding other operators for the rest of our product suite. So coming to some of the challenges we saw while running Airflow for our customers, scale. So our customers, they submit a lot of DAGs in a short period of time. And since they are all submitted very in quick succession, there are lots of DAGs and tasks concurrently running on a single virtual cluster. And now this has heavy impact on our shared file system. And we have one database, which is common to all our Airflow instances for resource saving costs. But because of this, when one VC is under high database load, it has a slight impact on the entire database, and some of the product gets affected as well. And it's also a bit challenging for security. So we need to ensure that only authorized users are able to create and run jobs. So that's a challenge in itself, which I won't go too deep into right now. And we also had to containerize and autoscale Kubernetes Airflow so that it works well for customers. And since what we noticed is there are very few Kubernetes Airflow offerings, and we were one of them. There are some of default Airflow behaviors that caused us some issues. So right now, customers, they face issues updating DAGs that are currently being executed. And Airflow, we also had issues with the failure handling and retry of DAGs in Airflow. So what happens is when your system is under high load, our Airflow by default, I think it's 9. There's a task retry limit is set to 9, and this puts even more load on an already strained system in case some of your tasks fail due to intermittent network or other issues. And so because of this, we had to come up with some certain workarounds or something to mitigate this problem. And after also proper cleanup, we struggle with proper cleanup in Airflow of CD jobs that get killed. Sometimes some resources are left around. So that is another thing we have to actively work on. These are some of the experiments we run for running Airflow at scale. So one of them is we increase the number of jobs, which is actually one CD job translates to a DAG. And as you see, as we hit 500 or 1000 or 1500, the job creation type balloons up. But until 500, the response time is roughly okay. So that's one of our metrics. Another one is, let's say we have multiple different number of DAGs that we create parallelly, but the total number of tasks also we reran the same 200 DAGs with 7 tasks each, 200 DAGs with 15 tasks each, and we keep rerunning it. And as you can see, the total duration for all DAGs to finish, it increases. So these are some of the metrics we actively track and try to improve release on release. So what have we done so far? Right now, we have made improvements to our Livy and Airflow installations. So right now, from Airflow, when we submit 250 DAGs that are orchestrating Spark jobs, we've from past releases, we've reduced our total time of the entire thing to run by 30%. And per Airflow, right now, we're able to run 1500 DAGs. And each DAG has 10 tasks in our benchmark test. So 1500 tasks are able to run in full load. And right now we have a parallel limit of 250 tasks at a single moment of time. So we're able to do this without any errors, but we're actively working on improving these metrics. So coming to other uses of Airflow at Cloudera, apart from selling Airflow, we also use Airflow heavily internally. So one of our key use cases is for our testing infrastructure. So earlier for running tests, what we used to do is use a lot of Jenkins jobs and internal tooling to add dependencies. But what we noticed is each time someone wants to create a slightly complex test and say that, hey, we need one dependency on another task or something like that, we had to add more REST APIs to our internal tooling, and which is not a scalable process. So to solve these issues, we started using Airflow for our orchestrating our tests. As you can see, this is one of our sample tests that we run for one of our product suites. It's fairly complex. You have a few startup stages which spins up the cluster, and you have multiple different errors / conditions you check for in the middle. Once all your tests are run, you go ahead and spin the cluster down and delete it and make sure that no resources are left around for cost saving. Now, one beauty of Airflow that we felt is like two parts. One is if suddenly, let's say in this step earlier, if your test used to fail, we'd have to rerun the entire thing again. And so some of our tests take multiple hours to run. And so this leads to wasted resources and etc. for rerunning it from scratch. But with Airflow task level retries, if one failure occurs, we can quickly go ahead and diagnose what caused that failure. Was it a config issue? Was it a product issue, etc.? And if it was easily fixable, because many a times it's some config issue in our internal tooling, we quickly fix it and rerun that task, and then our test can continue. And we've also built a lot of operators, which are very useful for us. So some of these tasks reference our internal tooling. So we built operators for our internal tooling so that we can quickly build modularizable components. So what that entails is each testing team can build components which other testing teams can use. And this scales very well so that you don't need to rewrite code again and again while creating your testing infra. So yeah. A bit about Cloudera, where, as I've spoken about, we are heavily built on open source. Our entire product stack uses a lot of different open source components. We have committers in many different Apache products like Phoenix, Atlas, Nox, Ranger, Hive, Taze, Zookeeper, Impala, Unicorn, Hadoop, NiFi, Spark, HBase, etc. Some which I have not listed on the slide, and Ozone as well. What we've just started out on our Airflow journey. So a lot of our developers have started contributing PRs to Airflow, and we want to increase our contribution to the community so that we can build a better Airflow together. So coming on what we are looking forward in our Airflow offering in the future. So as you saw, we had a limited set of operators right now. We've just recently started. So we want to add more Cloudera operators for the rest of our product suite, machine learning, etc. We want to spend more time increasing our open source contributions to Airflow. And we want to improve our low-code editor so it's more feature-rich. Right now, what our customers do is they can modify the DAG once it's created. But there are some corner cases. We want to ensure that the low-code editor customers never have to touch a DAG itself. They don't even need to know what Airflow is or even care about it. And we are actively working and investing heavily on our scale limits, and we're working each release to improve those metrics that we showed you earlier. So yeah, that's the end of my talk. Thank you. Any questions? So for per job, let's say I showed you that jobs page right now. Let's say each DAG I make a modification and I keep running it. I have one view of all my past runs. That's from a product perspective. So let's say I'm a user, I make modifications. I can see a graph of duration of my DAGs, and I can quickly notice that, hey, this one suddenly shot up. What config change did I make? At a scale perspective, what we do is we run aggregate experiments. So we run a lot of them and see, okay, how many failures are we hitting? What are our bottlenecks in our, because it's a, apart from Airflow, there are multiple different Kubernetes services, services running in our clusters. So we have to see which bottleneck are we hitting, which memory limit, CPU, etc. And Kubernetes scale also we are working on. So like, how do you optimize your pod CPU request limits such that multiple pods can run together cohesively in one cluster? Airflow pools, not too sure. Any idea?
Burst of Airflow, this thing, but that is mostly from a testing, from a scale testing.
Yeah. So this one. Which one? So each DAG, so this is one experiment for when we run with a number of tasks, right? So here each total number of tasks were around like if you can extrapolate it, like few only, but here there are 3K tasks in total. So it's DAGs plus we increase the number of tasks per DAG. So like 300 DAGs, we rerun the experiment here with a few number of tasks per DAG. Let's say, for example, 1 here, then we run it with 10 here. So you have totally roughly 3000 tasks total. And then here we run it with 30 tasks per DAG. So each time we do that, our total duration from start to finish of our entire workload keeps increasing, and which is expected because you're running totally number of tasks is what matters in Airflow, right? For some parallelism we had, but again, as I said, we are hitting this 250 limit. Hmm.
And given unlimited resources in the cluster,
Hmm.
and assuming you are using different executor,
Mhm.
right? And ideally, like I just situation is like there should be a little bit extra latency, but
No, but there'll be one parallelism limit, right? Even in Kubernetes executor or something. Exact details I'm not too sure of. But
So the other thing is there is a parallelism limit. Plus the customers, the users, they want to restrict the cluster to a certain pool.
yeah.
We cannot have, especially when it comes to public cloud, we cannot have unlimited resources.
So fairly simple. We start off with we increase number of DAGs, increase number of tasks per DAG, right? If the so again we look at aggregate performance. Some percentage of them have failed, some have not. When it fails, we dig in and see what caused it to fail, which bottleneck of the system we're hitting, work on improving that bottleneck, and move from bottleneck to bottleneck, release to release.
And how do you manage the dependency chain? So, for example, I put a tag and that required a new set of dependencies. So, how do you install those dependencies?
So we have a fixed set of operators which we install per VC. So each VC we
Python operator, I can just say import pandas, right? Pandas is not there.
Yeah, for that we use these Python environments which we create. Custom user can either upload their requirements.txt file, which would list their library and this thing, or they can build that virtual env and give it to us, and then we use that to get all the Python packages. It runs in Docker at the end, but we'll do the pip install requirements.txt, before running. So it's a shared resource. So we have like resources. I spoke to you about shared files. We have a shared one type of resources, Python environment, so that you can reuse within Airflow and in our Spark jobs. No, it's during build of the Python environment. So when you upload your requirements.txt, we build the Python environment and reuse it and mount it onto each job. So what for specific Airflow alerts, what we do is we take, so we use support email alerts for both our Spark and Airflow jobs. We let the user during VC creation specify them, and then we override the alert for each instance of Airflow. But we don't support modifying all of the configs. So again, the different customers have different security requirements. So sometimes it's just 2 or 3 data engineers who manage the entire product. Larger companies, they have clear admins who have to manage the cluster, and users who just create the DAGs and run them, or Spark jobs. So again, we support both this thing. You specify your access control at VC or at a higher level in our product in the management console. All of it trickles down and comes down till the end. Yeah. So we have one API which sits in front of Airflow. So we know which Cloudera user has triggered a DAG, and if you go to that jobs page, you'd see that, hey, created by Surya or something like that.
So that's true for both our Airflow and Spark jobs. We have our own management APIs that run on top of both Airflow and Spark, and that helps us with auditing, management of the jobs, and etc. Yeah. It is visible in the UI. As a user, you can take a look at it.
How can we expect any?
Lineage information for airflow by that you mean who ran what when, no?
Not like that. How the DAGs are, how the data sets are going, how the tasks are, traverse from task 1 to task 3.
Okay, so right now we've just used, if I'm not wrong, only Airflow support for tasks. So again, Airflow, what I've heard from some community tasks is, it's not meant for data transfer in a sense that, hey, we should, this task will send data onto this. It just sits on a top layer. It's only for orchestration. That's similarly what we've built here. We've just given Airflow as is with some modifications, but minimal. So in that case, from our Airflow DAG point, you won't know that, hey, this data is flowing into this. We've thought about this problem, but we've not built any products for the proper data thing like flow or something like that. Is that what you mean?
Actually, in Apache Airflow, we were able to configure the open
Mhm.
we can able to expect anything. Since you are managing this Airflow, is there any way you are providing this configuration?
I don't think so. I'll have to check. Vedant, any? Not sure, but yeah. So that was a recently added feature or long back, I think. 2-3 years. Okay, okay. We'll check, I think.
But like a couple of years back, there was a support for headless Apache headless.
Okay, okay.
Lineage, but I think nobody used it.
Okay.
So we use Atlas for
Lineage in our other
in our
products,
Spark jobs.
Hive and everything else.
Hive and Spark jobs, we heavily use it.
But I think recently this is open lineage is something like. Oh, you have tried it for slide open lineage. Right now we are doing some POC in open lineage.
Okay, okay. We'll look into that. Sounds interesting. Any other questions?
Yeah, last slide. Is there any reason you club the offering with this part? Like why not Airflow can do the first class citizen and we the offering itself?
I can take that. So Airflow is heavily used by our data engineering customers, and they want a tighter integration with Spark.
There are so many things that engineering use nowadays, right? Not only Spark. Right? There are so many different systems. Not only Spark. So yeah, like question, right?
Yeah.
Why tied up Airflow with something else? Like why bundle Airflow with something else? And why not
Keep it as its own orchestration software. Yeah, we've thought of that. It's all internal discussions. I can't fully reveal what is.
So actually, the reason we had Airflow was a lot of our customers used to use Oozie in the on-prem form factor. But we felt that Airflow is a better offering as compared to Oozie. And that's how Airflow came into picture. We started providing orchestration. It just started helping with orchestration of Spark jobs. And then eventually Airflow came mainstream into the data engineering platform for us.
We've spoken to our customers, so full details I can't reveal, but we're looking at both options. So what I'll say.
what was the Airflow version currently?
2.3.4, if I remember correctly.
How will you facilitate this deferrable operating?
Differable operators. What do you mean by that? Sorry, could you elaborate?
Means the Airflow 2.0, Airflow above the version 2, they are offering some trigger action, like the schedule kind of thing. So it will facilitate the usage of deferrable operating.
So triggered action means some action somewhere triggers an Airflow DAG or something.
Resources for some time. Because we trigger the job, Spark job. Once we trigger the Spark job from our Airflow thing, the task need to be wait for a Spark job to be completed. So the Airflow will put it into the trigger deferrable state, that task, which means we can use this resources for something. So is there anything you are doing?
Those details, Vedant,